All right, so this is chapter 22. This is the GitHub migration. So what we're going to do, we're going to build on that last chapter we had where we built out that GitHub metadata backend, but now we're going to act like we're a couple months or a year down the road and we want to add a couple new entities, we want to add a couple new attributes, and we also want to migrate an access pattern that didn't work out for us. So this is really useful for figuring out how you can evolve your access patterns over time, which is something I get asked a lot. We're going to follow the same process that we followed for all of our data modeling examples. Understand your application, understand those migration patterns that you have, build your ERD. Here you're just going to update that ERD with your new entities, with those new relationships. You're going to define your new access patterns and figure out what you need to handle, and then you're going to get in, design your primary keys, secondary indexes, new attributes you need to add, etc. So let's get started and understand the application and understand the changes we're going to make. Again, we're just updating our GitHub example, so we've already done a bunch of it, but let's walk through what we're going to do here. Number one, we're going to add a code of conduct to a repository. So this is something that GitHub's added in the last year or two, where you can specify a code of conduct on your repository. It specifies, if you have a public open source repo, how the community members should interact with it, what they should expect from maintainers, and what community members, how they should behave as well. The next thing we're going to add is support for GitHub gists. Now, gists are just little snippets of code that you can create in GitHub if you want to maybe post an example and then send that over to someone. You don't have to make a full repository, but it has a lot of the same characteristics of a repository where it can have comments, it can have stars, it can have different files, things like that. A couple of things to note about gists. Number one, they belong to a user. So, and they can only belong to a user. They can't belong to an organization. And a user can have multiple gists. So there's a one-to-many relationship there. Additionally, when you return those gists, they're going to be returned in descending order. So you're going to get your most recent gist first. The next thing we're going to add are GitHub apps, and apps are little functionality that you can add to your repo to perform some actions. They're often provided by third-party providers such as CI/CD solutions or testing solutions or different things like that. Here are a couple apps in the GitHub marketplace. Apps are created by an account, so an app can belong to either a GitHub user or a GitHub organization. And if you've created your apps, you'll see them right here in your settings. So you can see there's a one-to-many relationship between an account, either an organization or a user, and those GitHub apps, because a user or an organization can have multiple apps, but an app will belong to a specific user or organization. Additionally, apps can be installed into different repos. So you can see here, I've installed the Netlify GitHub app into one of my repositories. This helps me deploy a static site. There's a many-to-many relationship between GitHub apps and GitHub repositories, because an app can be installed into many repos and a repository can install multiple apps. Finally, the last thing we're going to do isn't adding a new access pattern, but actually just fixing a previous access pattern. So this is the issues page, and we talked about how you can filter between open and closed issues on GitHub. And we talked about different ways to implement that, and the way we implemented it was doing a filter expression rather than building it into our key. Maybe we get down the road and we find out that isn't working so well for a couple reasons that we'll get into. So we're actually going to change how we do that. So again, just understanding our application here, we're doing a migration of some GitHub metadata. We're not, building the entire thing. We're just evolving this as it goes along. We're adding a code of conduct to repositories. We're adding GitHub gists, which belong to individual users. We're adding GitHub apps, which are owned and created by accounts, either users or organizations, and then can be installed into different repos. And then finally, we're refactoring how we do open and closed issue and pull request retrieval. All right, next step we want to do is build that ERD, that entity relationship diagram. We've already got a pretty advanced ERD from the last chapter when we built out the bulk of this, but we'll just add on here. A few things added on here, they're all in red. Let's start in the top left-hand corner. You can see that we've got this new gist entity. Users can have multiple gists, so there's a one-to-many relationship between users and gists. Second, in the bottom middle, you can see that code of conduct entity that we've added on there. A repo can have a code of conduct, but it can only have a single code of conduct. So there's a one-to-one relationship between repos and codes of conduct. Finally, there in the middle, we have GitHub Apps, and it's kind of interconnected with a lot of different things. You can see both users and organizations can own GitHub Apps. So there's a one-to-many relationship between a user or an organization and GitHub Apps. And then finally, a GitHub app can be installed into multiple repositories. So there's a many-to-many relationship between GitHub Apps and repos via this installs relationship. All right, just to quickly summarize what we have here, we've got 3 new entities, the code of conduct, GIS, and GitHub Apps. We also have 5 new relationships. One of those relationships is one-to-one, 3 of them are one-to-many, and then one of them is many-to-many. Now, usually we build out our entity chart here. We've already got a pretty complex entity chart, pretty full entity chart from that last chapter. I'm going to remove a few of these that aren't going to be relevant, things like stars, issue comments, reactions, things like that. So let's narrow it down a little bit. We take some of those out of there. And then we've added our new entities at the bottom, the code of conduct, the GIS, and the GitHub app. Finally, last thing we need to do before we get started is define our access patterns. First access pattern we have is around that code of conduct, and that's adding a code of conduct. And then every time we retrieve the repo from then on, it'll include that code of conduct entity on it. Additionally, we have 2 access patterns around GIS. Number 1, creating a GIS. A user, might create a GIS that has a little bit of sample code. And then second, we want to view GIS for a particular user. Then we've got 4 access patterns around GitHub apps. So number 1, creating a GitHub app. This is going to be done by an account, either a user or an organization. Number 2, we want to install that GitHub app into various repositories. And then we have a few get many type access patterns. Number 1, view GitHub app installations overall. And then number 2, view GitHub apps for a particular repository. Finally, the last thing we want to do here is refactor those issue and PR access patterns. So these aren't new access patterns, but just a refactoring here. We're going to change how we retrieve open and closed issues and open and closed pull requests. All right, so now it's time to dive in and actually do our modeling and update our primary keys, our indexes as needed. Before we do that, I just want to talk about migrations generally, and I sort of view them on a scale. So let's walk through the different types of migrations that you can do. The first type of migration is adding a new attribute. This is going to be the easiest type of migration you're going to do. If you're just adding an attribute to an entity, it's usually pretty simple. You usually don't need to do any migration in DynamoDB. You can just add that in your application code and good to go. The second type of migration is to add a new entity with no relationship. And when I say no relationship here, I mean no relationship that needs to be modeled out in an access pattern. So there's no sort of fetch parent and related entities access pattern there. You're just adding a new entity that can be in its own brand new item collection. And again, this is only a change in your application code, nothing you need to change on existing items in DynamoDB. The next level of difficulty is adding a new entity that has a relationship but into an existing item collection. So maybe you have a parent item and you're adding a new type of entity that's related to that item, but there's an existing item collection that you can just slide that right into. If that works out, that's great. It's easy to add. You just have to update your application code without changing any items in DynamoDB. The next 2 are a little more difficult, where you're adding a new entity into a new item collection. So this might be where you have a relationship with an existing entity, but there's no item collection that works to handle that relationship. So you have to create a new item collection in some sort of secondary index. And this usually means adding new attributes to that existing item. So you're going to have to do a little change there in addition to your application code. Finally, the most difficult one is just migrating existing patterns, and we'll see that with the open and closed issue. And not only do you have to transfer patterns, but you also have to update those items and do a migration there. So that's more difficult. So I like to break it down in this way. Those top 3 migrations, those are all additive, where the only thing you need to change is your application code. And as soon as you start writing those, they'll work. You don't have to do anything to existing items. The last 2, they both need migration, where you need to do something with existing items that are in your table. You need to add new attributes to them so they can be indexed in new secondary indexes. So you need to perform a migration script on those ones. Now, as we work through these different migration patterns that we have, I'm basically going to follow this script and try and move from easiest to more difficult. So that's how we'll handle these. The first one we're going to handle is modeling this new code of conduct entity that we're adding to our application. And let's think about what that looks like. A couple properties we have here. Number one, there's a one-to-one relationship with that repo entity. And we talked about this in the last chapter around payment plans, but almost always when you have a one-to-one relationship in DynamoDB in NoSQL, you're just going to attach that to that parent item rather than split it out as a second item. A few exceptions to that, but probably not relevant here. The second thing you need to know about the code of conduct is that it's not required on a repository. So existing repos that don't have this, that's fine. This is just going to be purely additive. And in that sense, we'll just add this as an attribute on our repository object. So we change our application code so that we can write this code of conduct attribute for repos that want to have it. So we add a new endpoint that people can do this. You know, it updates that repository object, but we don't really need to do anything in DynamoDB. It's just an application change. So this was a pretty easy one. If we go update our entity chart here, you know, we had code of conduct listed, but it's actually not a separate entity. It's just attached to that repo. So there's no PK or SK pattern for that code of conduct. All right, so let's move on to our second additional access pattern that we're going to have here, and we're going to add the gist entity. So let's think about what we have with the gist entity. Two big points we need to think about here. Number one, there's a one-to-many relationship with the user, because a user can have multiple gists, but a gist will belong to just one user. And again, it only belongs to a user, not to an organization. Organizations cannot create gists. Second thing there is we want reverse chronological sorting. Whenever we have chronological sorting like that, you know, we lean towards using that KSU ID, which gives us a unique identifier, but also gives us chronological sorting when we need it. Let's take a quick look at what our user looks like, you know, since we're adding this new relationship. And this is what the primary key looks like for accounts, so users and organizations. And one thing to note here is there's nothing in that account item collection on our base table in the primary key there. So what we can do is just add the gist right into that main item collection. So this is how we're going to model it. The gist will have a PK of account, hash, and username, and the sort key will be hash gist ID. So let's take a look there. This is what we have here. So we have our account with that account item, but we also have the gist items in that same item collection, which is going to allow us that query operation to fetch the account and all gists for the account. If we go and look at our entity chart there, we can add our gist in there. Again, that PK is going to be account hash username, and that SK is going to be hash gist ID. Okay, let's move on to our third new access pattern here. This is going to be modeling out GitHub apps. We have two different concepts that are going on with GitHub apps. Number one, GitHub apps belong to an account, so either a user or an organization, and there's a one-to-many relationship there because an app is going to belong to one user or one organization, but a user or an organization can have multiple GitHub apps that they're creating. Second, GitHub apps are installed into a repository, and there's a many-to-many relationship there because a single app can be installed into multiple repositories, but also a repository can install multiple apps. Let's get started with that first concept, GitHub apps belonging to an account, and handle that Git account and GitHub apps for account access pattern before we move on to that many-to-many one. If we look again at our accounts item collections on our main table, this is what we see. And one thing to remember there is that users and organizations sort of share the same primary key space, right? Where we have account, hash, and then username or org name, because we want to make sure that name is unique across both the users and orgs. So as we model out this one-to-many relationship, we need to make it work for both users and orgs, and that's a little tricky. First off, if you look at the top, that's a user item collection, and the ordering it has there, our first gists are in there, and then that account parent item are in there. But then if you look below at the organization item collection, we have we have it flipped where the organization comes first and then the membership. So it's a little tricky to understand where we would put that GitHub app. Would we put it before that parent item or after that parent item? It would actually have to be different across organizations and accounts, which could get tricky. So we're not going to do that here. We're actually going to model it into a secondary index. So let's build out this GitHub app like this. First, the PK for that GitHub app is going to be app hash owner name hash app name, and the sort key is going to be the same, app hash owner name hash app name. Then in our GSI1 PK, we're going to have account hash and the owner name, whether that's the user or the organization, and then that GSI1 SK will be app hash app name. At the same time, to these user and org items, we're going to add GSI1 PK and GSI1 SK values, which are going to be account hash account name, which will be username for the user and organization name for the organization. Let's go look at our table with these changes in here. First of all, at the bottom here, we've added a couple apps, GitHub app items down there. They're using that app hash owner name, hash app name pattern. Another thing we're doing here is we're adding in those GSI1 PK and GSI1 SK values to our users and to our organization. Now, if we look at our GSI1, we can see that in that item collection for a particular account, we can see both that account and those apps that are created for that account. So in this user in Alex Debris' item collection, we can see that Alex Debris item, but also the 2 different apps that Alex Debris has created. Now let's go back to our base table real quick because I did skip over something important. I talked about adding the GSI1 PK and GSI1 SK values to our account items, to those users, to those organizations. But we've been having this application run for a year, multiple years now. We've got a bunch of users. We've got a bunch of organizations. I mean, what does that mean to add in these GSI1 PK and GSI1 SK values? We need to run some sort of migration script to go out, find these items, and decorate them with new attributes. Let's go look at this migration script in code to understand what that's like. And with these migrations, you can usually think of them as having 2 different steps. Number 1, you're going to scan that table to identify the items that you need to update. And number 2, for each item that you find that needs an update, you're going to actually go out and update that item. So let's look at our code here. We have this migrate all accounts function. And what I'm going to do is just set up these basic scan parameters where I'm saying, hey, go on my table. I'm actually going to do a filter expression here to just filter down to just the types of items that I want to update. So I want to update the user item and the organization item. You know, I've kept that type attribute on every single one of my items, so it's easy to identify those items. And then I'm just going to start this while loop, and while true, I'm just going to loop through my table, scan it, and work through those different pages. So here's my scan operation here. Then I check to see if I have any results, and if I do, I'm just going to run this update account operation for each account that I found. So for each user, for each account or organization that I've found. And then at the bottom here, if I've found if there's an last evaluated key on that scan result, that means there are additional pages. You know, I hit that 1 meg limit on a scan. I need to keep scanning through that. Otherwise, I'm just going to break out of this loop. Let's go take a look at that updated account function here. So we have this here. I'm just passing in that item there. I need to figure out if it's a user item or an organization item. So I'm just figuring out which deserializer I need, either the user from item or organization from item. Once I do that, I create my entity from that item, just like I would if I'm using it in my application. And then I'm just running this DynamoDB update item script where I'm saying, hey, here's the key. I need to update this expression and set these new attributes on it. You know, the GSI1 PK, GSI1 SK. These are both methods on that entity, so I don't have to calculate that myself. I run that. And then for each user, each organization that I get, I'm going to run this script. It's going to update all those items as I'm scanning over my table. So, you know, it sounds scary to have to run these migration scripts, but once you've done it 1 or 2 times and you work through the process, you understand it's really just that 2-part thing. First of all, scanning your table to identify the items you need to update, and then number 2, updating those items as needed. So let's look at our entity chart after adding this GitHub app and our new attributes on our account items as well. You can see we've added that GitHub app at the bottom. The PK is going to be app hash owner name, hash app name. The SK is going to be the same. If we go over to that GSI1, you can see that user and organization both have new attributes there. They're both going to be account hash and then account name, which will be username for the user and org name for the organization. Likewise, that GitHub app is going to be account hash owner names, which will put it in the same item collection as its owner, whether that's a user or an organization. And then that GSI1 SK is going to be app hash app name. So that was the first concept we need to handle with GitHub apps, that one-to-many relationship. Now let's model the second part of that, which is that many-to-many relationship between an app and a repo. And usually when you have that many-to-many relationship like this, we're actually going to represent it as an item itself. So we'll be creating an app installation item. We just need to think how to handle both sides of that, where I can say, hey, give me an app and all its installations, or give me a repo and all the installations there. Now, we're fortunate we just created this GitHub app item concept here where it's in its own item collection in that main table. So we can put the installation right in there in that main table to handle that Git app and installations workflow. Additionally, if we look at our other GSIs, we can see that in GSI1, the repo has pull request modeled in there, but it can add another access pattern in there if we want. So let's see how we're going to model this out. we're going to create this GitHub app installation item. That PK is going to be app hash owner name hash app name, which is going to put it in the same item collection as the GitHub app itself. And then that sort key is going to be repo hash repo owner repo name. And again, the combination of all that stuff will make sure you don't install an app multiple times into the same repository. Then to handle that, get repo and all the app installations for a repo, we can have the GSI1 PK of repo hash repo owner and hash repo name, and then the GSI1 SK of repo app hash app owner hash app name. If we look at that here, here's our table. You can see at the bottom we've added a app installation item, and it's in the same item collection as the app itself. So we see that installation there. We've also got these GSI1 PK and GSI1 SK values that will group those together. Notably, the repo already had these GSI1 PK and SK values because it was doing that with the pull request. So we didn't have to do anything there. So this is actually a completely additive change. If we go look at our secondary index, it looks like this, and we can go down there. We can see there's our repository, which has the repository item, but also all the app installations for our repository. So if we go look at our entity chart, we've added this GitHub app installation at the bottom where the PK is app hash owner name hash app name, and the sort key is repo hash owner name hash repo name. And again, that's going to group it with the GitHub app itself, so you can see all the installations for an app. Then if we look at GSI1 PK, we can see there's this GitHub app installation item that has repo hash repo owner hash repo name, which puts it in the existing item collection for that repo in that GSI. The GSI1 SK for that app installation item is going to be repo app hash app owner hash app name. All right, so let's move on to our last migration pattern here. This is going to be the most difficult one. We're going to be refactoring an existing access pattern. This is going to be refactoring how we handle issues and pull requests. Just as a reminder, here's that issues page for GitHub, and what I've outlined in red there is that open and close filter. So when you're looking at a list of issues, a list of pull requests, you can get either the open issues or the closed issues. Now, in our original example, we noted that wasn't part of our primary key for the issue item. What we had is we had a status attribute on our issue items, on our pull request items that is either open or closed, but we didn't have that built into our primary key, which means we can't do filtering directly on that key. Now, we said there are two different ways we can handle this filter on status. The first way, and the one that we did, you can use that filter expression, or you can do some client-side filtering, which means you're going to be overfetching data from your table and then filtering out ones that don't match. The other way you can do it is you can build it into your primary key structure, whether in your base table or in a secondary index. Now, I mentioned that I chose, the filter expression in the last one because there weren't a lot of filtering options. So since it was just two different statuses, open or close, it was pretty easy to maybe overfetch a little bit and filter down to what you wanted. But really, I don't like using filtered expressions when I'm doing paginated requests because it's hard to get the exact right number of items you need. So you often end up significantly overfetching or having to make multiple requests to keep going back and fetch more items until you find enough that meet your expression. So, after maybe a year or two of running this, we say, hey, we're spending more on read units than we want to in DynamoDB. It might be worth taking that right hit, having an extra secondary index that's more dedicated to this so that we'll have fewer reads. So what we're going to do here is we're going to use that composite sort key pattern that we talked about in the filtering strategy. And basically, we're going to include the status right into the primary key in the sort key of one of our secondary indexes. So the general pattern we might do is issue hash status hash, and then that issue number, which is going to be zero padded as we've talked about before. So let's take a look at what that looks like here. And here's what it could look like. There's one problem with this, and right here is the closed issues are at the very top of our item collection, but then that repo item is at the very bottom of our item collection. So this screws up that get repo and issues access pattern. We want to get the parent object as well as all the related objects because they're not next to each other anymore. Now, we've talked before about how you can do two one-to-many relationships in a single item collection. We've done this pattern a few different times. The key there is you need to be able to place that parent item, which in this case will be that repo, in the middle. So we'd want to have sort of closed issues on one side, open issues on the other side, and that repo is in the middle. What you need though is they need to be able to sort in different directions. So At a first glance, this seems like a bummer because we basically have 4 access patterns. We have fetch open issues, fetch closed issues, fetch open pull requests, fetch closed pull requests, and they're all sorting in a descending pattern, which makes it seem like we need to add 4 new secondary indexes. But let's take a look at how we're doing that again. Remember we talked about zero padding that issue number to create something that sorts a little better with what we're wanting. And what we're doing there is we're sort of adding some artificial characters in there just to help with sorting, but we can actually do the reverse there. And I'm going to use a strategy called the zero padded difference. We talked about this. It's kind of wacky. But what you're going to do is you're going to take the maximum number possible and subtract the actual number you want there. So we're zero padding this out to 7 digits. So the maximum number possible would be 9,999,999. If we have an issue number of 2, we subtract 2 from that. And then what we put on there is 9,999,997. So let's use this strategy and see what it looks like, how we can actually share a secondary index for 2 different access patterns. First of all, open issues, we're going to add these GSI4 PK and GSI4 SK properties. That PK property will be repo hash repo owner hash repo name, which is going to put it in the same item collection as the repo. And that GSI4 SK will be issue hash and then the issue status, which will be open, and then hash, and then that zero padded issue number difference. And we'll see in a second what that looks like. Likewise, for closed issues, we'll have the same GSI4 PK, but then the GSI4 SK will be hash issue, hash closed, which is the status in that case, and then just the zero padded issue number without the difference. Finally, we'll have that repo in there as well, which will be repo hash, repo owner, hash repo name. So let's see what that looks like in our GSI4. Here's an item collection for that DynamoDB book repo. You can see that we have a closed issue, we have the repo, and we have 2 open issues. If you look right there, we can go and fetch the repo and the most recent open issues as well. Even though they're going in an ascending fashion, you can see that the issue numbers are going in a descending fashion. That's because we're using that difference number there. Likewise, we can get the repo and the closed issues by starting at that repo and going in reverse order. That's going to get us that repo. That's going to get us the closed issues. We'll do the exact same thing with pull requests. We'll have to do this in a new GSI because we're already using all the other GSIs for things. So again, GSI 5 is going to use that same format for open pull requests, closed pull requests, and that repo item. So if we look here, update our entity chart, we've got GSI 4 PK with all those different items. All of them are going to have repo hash owner name hash repo name for that partition key. And then we're going to be using that sort key to make sure we place that repo item between the open and the closed issues. Likewise, same thing with GSI 5, going to put that repo right in the middle of those open and closed pull requests. Last thing I want to do before we move on is just show again what that migration looks like, because we're going to have to decorate those repo items, those issue items, those pull request items, every single one of them to add the GSI4 and GSI5 values on there. So here's that migration script I'm going to have. Again, it's called migrate repos, issues, PR, all that stuff. I'm setting up my scan parameters to scan my entire table. I'm using that filter to find just the item types that I want. So I want a repo, I want an issue, I want a pull request. So I'm using that in property in that filter expression to make sure the type is one of those options. As I filter over those, if I get some items, I'm filtering out the different item types. So in this one, I'm filtering out for repos, and then I'm calling the update repo function. Here I'm filtering for issues and calling that update issues function. Here I'm filtering for pull requests, calling that update pull request function, and then I'm just awaiting all those different promises. So that can happen in parallel. As I get a batch of items, I can go update each of those, and then I'll move on. And if I have some more results because it's paginating, then I'll run that scan again and keep working through that. Again, let's just look at 1 or 2 of those update functions here. So I have update repo. It's going to pass that item in. First thing that it's going to do is deserialize that DynamoDB item back into an object in my application so that I can run those different methods on it. Then I'm going to call update item using that key from that repo, and I'm going to set, for the repo, I'm going to set all 4 of those properties, GSI1 for PK, GSI1 for SK, and the PK and SK for GSI5 as well. So I'll set each of those, return that, and good to go. Likewise, if I look at an issue, doing the exact same thing, passing in this item, creating an issue, and then running update item on that issue, setting just the GSI4 values there because I don't need GSI5 for the issue, and getting those values in there. That's what our migration script looks like. It's very similar to the accounts one we did before. You scan your table, you find the items you want, and then you run an update on them. Very simple, very straightforward. All right, folks, that's the end of this migrations chapter. Let's just review what we covered here. Again, we added 4 new entities with 9 new access patterns, and this was on top of an existing, very complicated data model. So, I hear a lot of people worried about how do I evolve my data model and handle these migrations. I'm told that I'm supposed to model specifically for my access patterns and needs, and that's absolutely true, but it doesn't mean you can't add new needs after the fact. It just means that whatever you're doing, you need to make sure your table is designed for that, and you're not relying on filter expressions or scans or ad hoc queries in different ways. So what we did here, we handled that by adding 2 new GSIs, GSI 4, GSI 5. Those both have those generic primary key values. Those are used for those filtering on open and closed issues and on open and closed pull requests. We also had to do 2 migrations of existing items. So we saw that we had to migrate those account items, users and orgs, into that GSI 1 so that we could join them with the GitHub apps and handle those access patterns. Then we also had to migrate our repos, our issues, our PRs for GSI 4 and GSI 5.